morning, students. Once again, I welcome you to my video lectures on network analysis. In the last session, I explained mesh analysis, the importance of mesh analysis, and I completed the type 1 problem. Now, today I am going to take up type 2. In type 2, you will find voltage sources. Along with the voltage sources, that is independent voltage sources, you will find current sources. They are also independent current sources, but current sources on the perimeter of the network. See here, it is going to be perimeter, boundary. It is not going to be in the middle. It will be on the perimeter of the network. When it is on the perimeter, current sources are on the perimeter of the network, how to solve the problem? That is type 2. So follow the procedure. As usual, first meshes, count the meshes, either by inspecting the figure or the formula B minus N minus 1 formula. So number of branches 3, number of principal nodes 2, therefore number of meshes equals 2. So there are 2 meshes here. This is one mesh, this is another mesh. And mark the mesh currents in any direction you like. If you mark it like this, it is going to be X mesh current. Either you can take it like this or like this. That is Y. This is Y. Now, having marked mesh currents X and Y, so 2 unknowns, there are going to be 2 unknowns, X and Y. Now the question arises, I require 2 equations. But 2 equations are not required. The reason is, here this Y is in such a direction that I can take the value of Y. What is Y? See one thing, there is a current source here. Whenever a current source is here, it is going to maintain that current irrespective of resistance. Therefore, what is Y? Y is taken like this. If you have taken Y like this, then Y would have been 2. But you have taken Y in this direction. Therefore, what is Y? Y is equal to minus 2. Y equal to minus 2. So, out of 2 mesh currents, 1 mesh current is already known. If you take Y like this, then you have to write Y is equal to 2. So, out of 2 mesh currents, 1 is known. So, therefore, only 1 is unknown. Therefore, 1 equation is sufficient. So, 1 equation you can write by applying KVL to this mesh. Apply KVL 4 into X. 4 into X, because X is the only mesh current. Next, plus 2 into X is in this direction, Y is in this direction, X minus Y. Next, minus to plus, rise in potential, minus 2. Next, rise in potential, minus 5 equals 0. Therefore, rearranging 6s minus 2y equal to 7. 6x minus 2y equal to 7. Now, y value is known. Therefore, 6x minus 2 into y is minus 2 equal to 7. Therefore, 6x minus into minus plus, if you transfer to this side, 7 minus 4, that is 3. Therefore, x equals 3 by 6, that is 0.5 amperes. And x is coming out to be positive, therefore assumed direction is correct. Therefore, x equal to 0.5. Now, having calculated x, now rub off the mesh currents, write branch currents. Now x What is X? X is 0.5. X is 0.5. Next Y. Now one thing, here this is 2 amperes. What is current through 2 ohms? Now the current through this branch is applying KCL here, it is 2.5 amperes. And 2.5 amperes is entering the negative terminal of the battery. That means this battery is still supplying power. It is supplying power. What is the power supplied? Power supplied equals 2 into 2.5. That is 5 watts. So this is what is known as type 2 problem. In type 2 problem, you will find a current source on the perimeter of the network. Thank you.